I've been working in high-tech companies all the time, so in different areas like semiconductor, automotive, electronics, and I've been working in high-tech, deep tech companies with high growth. That's also why I was very interested to join ATLANT. Yeah. Yeah, because I was really sold by the project. They have a disruptive technology, and it's combination of very innovative company, disruptive technology, and also bringing sustainability on the market for manufacturing processes. Yeah. It's a very diverse culture. It's a very international company, so I really like it. And this is like what makes the company even more interesting.
I originally from Ukraine, and I have a PhD in economic. And I was a university teacher quite for a long time, 11 years. I taught different economic disciplines, including creative management and economic of enterprises and corporate social responsibility and so on at different universities in Ukraine. And basically in Denmark, when we moved to Denmark, I wanted to try something else. I was a bit tired from education area, and I wanted to find some place in the business. And ATLANT gave me this opportunity.
We are an equipment and manufacturing company, but we also want to work with the customers on joint collaborations and microfabrication as a service. And this is the part I also find the most exciting. The thing about selling a machine, just giving it away, there's not too much fun in that. I think it's a lot of fun when you can co-development with experts in respective markets. So what we do is we try to work in phases and build up pilots and work. So we start with the simplest test features we can do in little projects to evaluate the feasibility. And then the idea is to build up to bigger projects and collaborations together. And I think this is really exciting work to be. And this is what the customer success at ATLANT contain. It's the outcome of the machine. Basically, we don't really limit ourselves to either one market or one type of customers. The options is all around. We see right now with our nanofabricator light is a good market is the R&D and universities and material development as the application, because this is something the machine can handle in terms of size and resolution and things like this. But in the end, big corporations and industry will benefit as well from the capabilities once the nanofabricator Pro is more developed and we can do more scaled up fabrication. We already now working on scaling up the technology. We just need to have the validation in the kind of R&D community first.
So there are many ways, that the technology is revolutionizing manufacturing. And the final way, I would say, is sustainability as well, to be honest. Like, the semiconductor industry is not really the most polluting industry in the world, sure, but still, it uses a lot of chemical. It wastes a lot because of the way it's currently produced in 2D and in a non-local manner, as what we do now. So at ATLANT, we don't need to, use those chemicals and spray the whole surface and remove what you are not interested in. So we really try to push the industry towards sustainability in a sense. If you look at how you create an application, like for example let's not say a device, but a full system that you would have in your hands, then it goes through different steps of production. And you have first material creation, then you have structuration of this material, then you end up with a small component, and then you integrate multiple of those components on the system, and finally you just wrap it in a nice package, and you have a nice application or system device or whatever you want to call it essentially. And the great advantage of our technology is that we bring an application or product, even I would say, in each of those segments. So from the material creation side, we enable discovery of new materials, discovery of stacking those materials together as well. Then on the structuration side, essentially we have applications on being able to deposit on multiple of substrates, like flexible glasses or just standard semiconductor substrates. We also enable essentially structuring without lithography, which is a step, processing steps usually used in the semiconductor industry. So it's much quicker, we could say, and much cleaner as well. Then on the next step at the device level, we enable new types of structures, so which means devices with enhanced performances, essentially, or that are produced much quicker than it is currently. And finally, on systems, it's system integration. So we can make devices that are basically a collection of multiple devices. And so we reduce the size and we can integrate that into an already existing system. So we can boost, the final component or device.
The DAL technology is already developed. The proof of concept is well accomplished. What we are trying to do is to expand its capabilities. So we're trying, for example, to add some more options there, so it can expand the processing capabilities and materials capabilities. Right now, there are some limitations, let's say, in terms of the materials that we can develop. So we need to expand this technology so we can develop more materials, or even the processes. Right now we are able to deposit materials, but there are other things that we can do, which is etching, for example, doping, or cleaning of substrate, and these are processes that would require some changes in the technology or even in the setup, I would say. So we do explore this kind of domains and work on. On the long term, what we are looking after is having those hubs where ATLANT's technology is available for everyone, for big industries, but also for small SMEs, so they can come and they can also use our technology in those hubs, physical hubs, in different parts of the world, and so where they can also be working on prototyping for their specific application.